Okay, welcome to Planet Geography, and today we're going to deal with the hydrological cycle. It's quite complex, that's why the video is quite long. It deals with quite a lot of different aspects. But let's just break down at its very core what it is. Hydro means water, logical means order, and cycle means to go round continuously. Okay? So, if you break it down, the hydrological cycle just means water moving around in a continuous cycle. Now that cycle moves billions of tons, and billions of tons of water around our planet every single day. So, where does the energy for this? If we're going to move anything, it will require energy. It's completely powered by the sun, and we'll look into how that operates in a second. Okay. Key things that we need to know when we look at the hydrological cycle is that the water will always be in two states. It will either be in a stored state or it will be in a flow state. Okay? Now what does that actually mean? Stored states are your lakes and your oceans, the classic big two examples. And you see it's a large body of water where the water isn't moving, it's sat there. Okay, a flow is when water is moving. So for me, the classic examples there are a river and a cloud. Okay, so the whole time we go through this, just be thinking, is it flow or is it stored, and so on. Okay, so let's jump into it now. Okay, so let's break this down into three sections. The first section I'm going to try and deal with is evaporation, condensation, and precipitation. Now, these are words that you kind of really should know. I'm sure you do know. So we won't spend too much time here, as there are other bits that are a little bit more complicated. The sun emits solar radiation, and we know that it heats the surface of the earth. We know from, for example, just one example, but there are others, that from cyclones, they heat up our oceans. This causes a change in physical state from a liquid to a gas, from our oceans. And we know this by the term, I hope you do, evaporation. So we have this warm air that's full of water, it's warm, moist air, rising. As it's rising, its altitude decreases. So we know that as we go up every 100 meters, we lose about 1 degree in temperature. So just like in our tropical storms, that is going to cause the opposite of evaporation. As it rises, it cools down. That's going to cause condensation. Yep. Condensation causes, so bad at clouds, it's going to form clouds to form. Okay, those clouds, and so if you think about our flows, our water is definitely being transferred at this point. Okay, so it's going to be blown along, and in this case, it's going to be blown inland. Okay. And it's going to get heavier and heavier and heavier until the cloud can no longer hold the water, okay? At that point, the cloud will break and we will have our final keyword of this section. I'm going to zoom through. Precipitation. Yep. Now we say precipitation because generally it's often rain, but it could be snow as well, okay? That is still part of the hydrological cycle. Okay, so we have precipitation. All right, I'm now going to cut and we're going to look at what happens when it reaches the land. Okay, so let's deal with the next stage. And this is how the kind of hydrological cycle interacts with vegetation. So when precipitation takes place, some of it is intercepted. Now, if you're a football fan, you should know what an interception is. But really, it just means catching the rain. Okay, so it kind of operates as an umbrella. That's why people often take shelter under trees when it's raining. Okay, so but some vegetation may trap and intercept our vegetation. So it's kind of like a store in a way, because at this point the water's not moving, it's sat there. And what can happen is sun will continue to shine. This kind of happens very much in rainforests. You will then have evaporation taking place from the vegetation. Now you kind of think, well, this can't be significant, all right? Well, if we use the Amazon rainforest as an example, 40% of the rain that falls on the Amazon rainforest, some people estimate, is actually intercepted and then evaporated off of our trees. And this is why we say rainforests actually create their own rain, because they kind of do in a way. Okay, so we need to know that that is a factor, interception followed by transpiration. And that's really it for this quick section, okay? Now we're going to look at, well, what happens when it actually hits the ground. For me, this is the most complicated bit, so stay tuned. Okay, so let's finish off the hydrological cycle. So we need to look at the ground and what's going to happen, because one of two things is going to happen. The precipitation that we see here, it may fall on ground that is impermeable. Okay, so you might say, impermeable means you can't break through. So you might say kind of Virgil van Dijk's Liverpool defence is impermeable. It means you just can't score. Same thing kind of happens here. The ground is impermeable, meaning the water cannot get into it. And so what it does instead is it flows along the top. So it may flow into drains, it may flow into rivers or tributaries, and then it will make its way to our ocean, where the cycle will be complete. Okay? So, surface runoff is really just a fancy way of saying rivers. Okay? The majority of surface runoff is rivers. Yep, and it's because the ground is impermeable. However, sometimes, I'm just going to get out my impermeable soil, and I'm going to make it the opposite of impermeable, and I'm going to make it permeable. This means that, I'm going to use a key word here, it's going to infiltrate into the ground. So, just like a spy infiltrates the ground, the water is going to infiltrate the permeable ground. Okay? And what it will then do is it'll work its way through rocks and stones and mud, and it will work its way through, and we say it's going to percolate. It's going to percolate through, if you're into coffee, making coffee, you have a percolator. It's going to go through the ground and the soil, okay? At this point, I'm going to almost go off my graph here, it's going to reach something that we call groundwater. Now, groundwater is kind of confusing because it always feels like I'm trying to draw in a river underneath our feet. It kind of is. Basically, there'll be cracks in the rock through which the water will move. Okay, it will still travel to sea level, but we'll do it through our feet. So we have this thing called groundwater. It's beneath our soil, beneath our rocks, and we call it through flow. There is through the groundwater. And so the water will return to its stores, that is the ocean, the biggest store of them all. And so you can see that then the cycle is complete, okay? And so what you really need to understand here is almost a steps by steps. It's a process, okay? Evaporation, condensation, precipitation, potentially some interception and some transpiration, some surface runoff, some groundwater flow. Throughout any of this, and you can pause the video and you can check me if you don't believe me, it's either stored or it's in its state of flow, okay? And this cycle that is powered by the sun and the rays that it gives out is moving billions and billions of tons of water continuously, okay? And it's been doing that for 6 billion years, okay? Guys, I hope that helps. If I can find an exam question, we'll jump in. If not, guys, I hope you found it useful, and like and subscribe for future videos, as I'll be making more as we move towards the exam season.